Okay, so in this video, I'm going to show you how you're going to use this PhET simulation in a lab that you're completing in class on Tuesday. So this lab is the green piece of paper in my packet. You should be able to complete all of this in class, but by watching this video before you come to class, you'll just be a little bit more prepared for how this PhET simulation works. So to find this PhET simulation, I gave you the link on the piece of paper. You can just Google like circuit construction kit DC only to head here and then make sure that you're in the lab version of the PhET simulation. So you're going to be making some circuits and using a voltmeter and an ammeter, you're going to be making some measurements. First, you're going to make two circuits that are in series. Then you're going to make two circuits in parallel, and then you'll be answering some questions to compare the two. So the first thing you do is you can grab these wires and you're going to start to set up your very first resistor or your very first circuit, which has two resistors, and it's also connected to a battery. So I'm going to do my best to make this look like the circuits that would look like in my schematics. If you just grab things and move them around. So I have my battery, I have some wires. I'm just going to add everything in first before I make sure that my values are all right. So this is a resistor, looks just like the resistors that we had in real life in our Ohm's law last week. Then I'm going to make the second side of my circuit, add another wire here. I'm going to add a second resistor, add a wire, and then add a wire. So some of the functions of how this works. One, when your circuit is connected, the electrons will move. So that's how you know everything is connected properly. If you want to disconnect something, you can just use these scissors and it'll break it apart. Okay, so if you click on each component, you can change its like value to whatever you're being asked. So we want the value of the battery for the first one to be 9 volts, which is great. We want one of our resistors to be 10 ohms, which is great here. But we want the second resistor to be 25 ohms, so we're going to change that there. So now that everything is set up the way that we want to, we're going to also make sure that we draw our schematic diagram onto our part 1 series circuit data table. So you've drawn the diagram for how these are in series. So the first thing then, you're going to start to make some measurements. And so for the 2 resistor circuit, you're going to record the voltage across the battery. Now it's in series, so it should be the same across the battery for this one here. So if we take our voltmeter, we connect it to each side of the battery. It's 9 volts. The only reason that it's negative is I'm just going to switch these. I must have been measuring from the negative side to the positive side. So now it's positive 9 volts. And we're going to record that as VT, voltage across battery. Next is you're going to use this ammeter. Now there's more than one of these that you can use. I think I like using this one better because you can just easily place this anywhere on your wire and read what the current is. This one would be, you'd have to connect it in series with the whole thing. So I'm just not as much into this one. So we want to find the current at a couple different places. We are going to use the ammeter to record the current through each resistor, just like we kind of did when we did our ohms lab. So you can find the current through the 10 ohm resistor to be 0.26, the current through the 25 ohm resistor to be 0.26. This makes sense to us because current is the same everywhere for something that is in series. We also are going to measure the voltage across each resistor. So we'll switch our leads to make sure that it's positive, but our voltage across this 25 ohm resistor is 6.43, and then across the 10 ohm resistor, we get a reading of 2.57 volts. So we record that in our data table. And then we write down our values, blah, blah, blah. Okay, then you should be able to kind of do some math and some calculations on these. So one, you're going to find the total resistance. So remember that resistance for something in series is additive. So you do 10 plus 25 is 35. The total voltage, so the voltage that's running through this resistor and the voltage that's running through this resistor should add up to our 9 volt battery. Double check that that's right. And then finally, you're going to tally up what is the total resistance or the equivalent resistance. You're going to use Ohm's law to solve that. Then you're going to repeat these steps and do it for a circuit that is in series with 3 resistors. And then you're going to start all over from scratch and you're going to build a circuit that is running in parallel with 2 resistors and then a circuit that's running in parallel with 3 resistors. So hopefully that just gives you a short introduction to how all of the different parts of this PhET simulation work. If you ever it's getting a little bit too crazy, you can always hit the refresh button and everything will go away. You can always have fun with these too, and if you want to start to make different when you're done, see what kind of different things that you can make in this lab. You can add light bulbs and switches. You can even change it to look like schematics. But before you go ahead and have fun, please answer 1 through 5 on your conclusion questions. Write them in complete sentences and use your group mates to use your best physics logic and kind of prove what you've learned over the last week about circuits that are in series and parallel. Alrighty, good luck, and I will see you guys on Thursday.